solving a multi-angle equation, if I can talk. So let's see here. We might want to remember that this is true, right? Right? Okay. So, if that's true, then we could try to make this look like that by dividing both sides by 2. And we could say 2 sine x cosine x is equal to 1/2. And then I could say sine, 2, better off the other way, sine of 2x is equal to 1/2. And that gets rid of our cosine. If you try to do it a different way, there's some pretty messy things that happen. And I may attach a picture of what that looks like if you try to do it a different way, a more creative way. So let's see here. We're going to say the sine of, maybe we'll use substitution. Maybe we'll say, what's the sine of u if it's equal to 1/2? Well, let's see. We're allowed to go from 0 to 2 pi. So where does this happen? Well, I'm pretty sure that u is equal to pi over 6. If I take the sine of 30 degrees, that's half. And also 5 pi over 6, that's half, right? And let's see, so if I say that 2x is equal to u, and I did, that was my substitution, then I'd say 2x is equal to pi over 6, and I divide both sides. Better not do that. Let's do it like this. Let's say 1 over 2. How about, that's better when I have a fraction, 1 over 2. And I'll say x is equal to pi over 12. So that's one of my solutions. And I'll also say 2x is equal to 5 pi over 6. And I will say multiply by 1/2. And I'll get x is equal to 5 pi over 12. That's another solution. So here are 2 solutions. But, this seems like we're not even halfway to pi yet, if you notice. We are, this is like pretty small. Pi divided by 12, that's pretty tiny. 5 pi divided by 12, that right there, that's not half. 6 pi over 12 would be half. So I have a feeling we have more solutions, and a graph might be helpful. It says use a graphing utility. Well, okay, true. We could use a graphing utility and kind of help it fill in the blanks. What else do we know? Maybe I should be highlighting the 2x part. The sine of 2x. What do we know about that? That means that things have been sped up. We've changed the period of our sine wave, right? So we kind of expect 2 times as many zeros. And so let's see. Let me show a graph of what we have here, if I can find it real quick. Let's try. Maybe this isn't the best. Oh yeah, it's right there. And so here we are. And we can see that, yes, indeed, pi over 12, there's 1. There's 1 right there. And then here's 5 pi over 12 right there. There's another 0. And then what's the relationship between the next ones? Well, let's see. We added 12 to get from 1. And it looks like we added 12 here as well. And I don't know how well this is showing you. I add 12 to go up here. And I also added 12 to go up here. And in other words, what I'm saying is 12 out of 12 pi. So I'm adding 12 out of 12 pi, or also known as pi, because normally my period is equal to 2 pi, but because I said the sine of 2x, my period is now equal to 2 pi divided by b, which is 2. So now my period is just pi. So things are happening twice as much, and they're separated by pi. And, it's hard to tell on this graph, but, 2 pi is out here somewhere, and maybe a little bit further. But the point is, we don't have any more zeros. There's one that happens, over here on this side of 2 pi. It's close, I suppose. Something like this happens. Bad drawing, but you get the idea. But it misses. I don't get any more zeros before I hit 2 pi. Where would the next one be, I guess I could ask myself. Well, I guess it'd be, if I'm adding 12 to this, I'd get 25 pi over 12. So you see that'd be, it would be that next pi over 12 after 2 pi. Okay, so I hope that helps to explain what's going on. So we get 4 answers to this one.